Hey boys and girls, just going to talk through displaying data with you. Okay, so let's say you've got a whole heap of random statistics. Where do we go from there? First thing, tally and frequency table. Okay, so let's say we've got a heap of discrete data here, such as, I don't know, 1, 5, 6, 1, 3, 1, and 2. Something random like that. Let's say we've got the number 1, 2, 3, 4, 5, and 6, and then we just tally up how many we've got. So how many number ones do we have? We've got 3. 1, 2, 3. How many number twos? We've got 1. We've got 1, 3, no 4s, 1, 5, 1, 6. Okay. Frequency. How many times this tally appears? 3, 1, 1, 0, 1, 1. Pretty simple tally and frequency table. So that's one good way of tracking data. Next thing is representing in a graph. Okay, so I've got here a column graph. Now don't get this confused with a histogram. Okay, column graph is used for any categorical data, and you know categorical data to be data that we split into categories. There are two types: ordinal, which has a rank; nominal, no rank. So if we were to split data into, let's say, discrete data in this case, okay, we've got the number 1 and that popped up 5 times, we've got the number 2 that popped up 10 times, etc, etc. This can also be represented in a bar graph. Okay, you can see the difference between a column. Columns are up and down, bar is across. So they are column or bar charts, so you can use discrete or categorical data for those. A histogram. A histogram is different. Okay, this is continuous data. So we're talking now measured data. So the heights of all the students in the classroom. Let's say there were 5 students with the heights from, this is ridiculous, but 50 centimeters to 100 centimeters. Okay, and here there were 10 people we can see here that were between 100 and 150. Okay, the next one will be 150 to 200, 200 to 250, 250 to 300, etc. Okay, so these give you ranges. That's continuous data, and that's when we use a histogram. We've got a stem and leaf plot. So if you're ever asked to do a stem and leaf plot, you'll have to do this. Now, I've got some random values here. So in the stem, let's say we had 0, 1, 2, 3. What do we do with the leaf? The leaf, okay, if we've got the number 5, for example, that would be 0, 5. Okay, in the leaf. Again, I put a comma and I go another 0, 5. So that indicates that there's the number 5 and the number 5 again. This stem would indicate anything in the teens here. So if I've got the number 12, I would write 1 and a 2 in the leaf. Here we've got the number 16, 1 and a 6 in the leaf. So that would indicate there's a 12 and then there's a 16. Now that's on the indication that this stem and leaf plot is in the teens. Okay, it could be in the hundreds, could be in the thousands, etc, etc. It will say down here. Okay, it'll say 1/2 represented as 12. It will state that down the bottom. 24 would be 2 in the stem, 4 in the leaf, and 32 would be 3 in the stem, 2 in the leaf. Okay, so that's your stem and leaf plot. Next one is our box plot. Okay, box plot I've drawn up here, you can see is represented with a minimum here at 1, a maximum here at 10. The other things that it is missing is, of course, a median in the middle. Okay, so that median in this case would be 5. Q3, which is quartile 3. Okay, and Q1 quartile 1. So Q3 is the median, okay, between the maximum and the median. Q1 is the median of the minimum to the median. All right, so we'll go through this in class, but the quartiles, quartile 1 is the median of all the values in the lower quartile. The median of all the lower quartile values, which is anywhere between the minimum, okay, to the median. The median's the middle. All right, Q3 is upper quartile. Sorry, upper quartile. All right, hopefully that makes some sense. Okay, so that is, of course, the median to the maximum. All right, it is the median of anywhere between the median and the maximum. So We've got pie charts next. Pie charts are categorical. These are outdated and not really used very often anymore. So if I was talking colours, let's say 40% people liked the colour blue, 40% liked the colour green, 10% yellow, 10% red. That's an example. Dot plots, we use discrete data. So if we had the number 1 pop up 1, 2, 3, 4, 5 times, okay, the number 2 popped up 3 times. That is a dot plot. All right, again, a little bit outdated. What we use is line, okay, and scatter plots for a lot of our investigations now. So I've just done an example of a line graph. So I've got down here years on the x-axis. Notice that that's the x-axis, that's the y-axis, things you should know. Each year, 1, 2, 3, 4, 5, and then I've got dollars in millions. So let's say the stock market in the first year went up by 10 million. The second year it went up by between 10 million and let's say 20 mil. Okay, etc., etc. And we can read off this line graph different stats, extrapolate and interpolate different data. Down here we've got a scatter plot. Okay, scatter plot we look at for trends, etc. And correlation, of course. Okay, trends and correlation. Really good to calculate from scatter plots. I've done an example of maybe a basketball player here. So down here on the x-axis we've got his seasons. Season 3, Season 6, Season 9. Gather from that what you will in Season 1, Season 2, etc. Points scored in each of those seasons. So let's say in Season 3 he or she was averaging around about 25 points a game. Okay, and you can gather trends and correlation from that. Hopefully this video helps you. Alright, give me a yell if it doesn't.